Okay, question 11 now on paper 1 from 2023, and we've got one of those favourite exponential modelling questions with logarithms a logarithm modelling question. Very, very, very popular kind of question, definitely in Edexcel, but across all boards. So super important question to know how to do, in my opinion. So it says the value in V pounds of a mobile phone T months after it was bought is modelled by the equation V is equal to AB to the power of T, where A and B are constants. Figure 2 shows the linear relationship between log to the base 10 of V and T. The line passes through the points 0, 3 and 10 and 2.79 as shown. Use these points to find the initial value of the phone. Well, we can see that when time is equal to 0, we've got the y-intercept here of 0, 3. Okay, so that means that the y value is going to be 3 and the y value is log to the base 10. So we can say that when t is 0, log to the base 10 is 3 from the graph. So therefore log to the base 10, if log to the base 10 is 3, reversing the logs gives us that v is 10 to the power of 3, so £1,000 was the cost of the phone. Just can't resist this, but when those smartphones first came out, no one thought that there was going to be a market for phones that cost £1,000. And because at the time all BlackBerry phones and stuff only cost like £200 or £300, and Steve Jobs was like, basically the customers will buy, I'm making my own market. So nobody had considered that there was even a market for phones that cost £1,000, but Steve Jobs made his own market basically. So, and the rest, as you know, is history. Okay, now sorry, I digress. Part B. It says find a complete equation for V in terms of T, giving the exact value of A and giving the value of B to 3 significant figures. Now, there's 2 different approaches for this question. I'm just kind of like stuck in my ways. I like to start off with V equals AB to the T, take logs of both sides, compare it with the equation y equals mx plus c, and use that to work out my A and my B. So let me show you what I mean. So we start off with the equation V equals AB to the T. So we're going to take logs of both sides. So log to the base 10 of V equals log to the base 10 of AB to the T. Now using the laws of logs, a product becomes a sum. So you end up with log to the base 10 of A add log to the base 10 of B to the power of T. So that's using the first law, using laws of logs. We've broken that up in that way. Now I'm going to use the power law to bring this down, the T down. So I've now got log to the base 10 of V equals log to the base 10 of A plus T times log to the base 10 of B. So I change the order now to make it compatible with y equals mx plus c. Now how do I do that? So I look on my graph and I see that my x-axis is t. Okay, so I'm going to put that where, I'm going to put the t where the x normally goes in y equals mx plus c. And I can see that my y value is log to the base 10 of v. So that's how I match it up with y equals mx plus c. Now the implication of this is that the gradient is giving us log to the base 10 of b, and the y-intercept is giving us log to the base 10 of a. So we can work out the gradient from this equation, from this graph, because we've been given 2 points. So our gradient is change in y over change in x, so 3 minus 2.79 over 0 minus 10, and that gives us minus 0.021, and that's log to the base 10 of b. So we reverse the logs and we say that b must be therefore 10 to the power of minus 0.021. And you work that out and that is 0.95279, and then to 3 significant figures that is 0.953. So there's our value of b. For a, we have that the y-intercept is 3, and that's giving us log to the base 10 of a, so therefore a is 10 cubed, so therefore a is 1,000. Okay, so we've now got our complete model over here. A is 1,000 and B is 0.953 when given to 3 significant figures. Okay, that's part B done. That's how I like to do that one. The other methods are available. Now, part C, this is being very nice in this question as well. This is our modelling assumption. So here for part C, what they're saying here. So they're saying exactly 2 years after it was bought, the value of the phone was £320. Use this information to calculate the reliability of the model. I guess the thing where you could get caught out in this question is, notice that they're saying it's 2 years, okay? So a common error, I think, would be to put 2 there. But if we're careful, if we look at the question says the value of a mobile phone in T months. So therefore, our value is 24 because it's months, okay? So we work that out, and that gives us, and even if we just go off the approximation that they said using 3 significant figures, then that gives us £314.94, which is about £315. Now, if we work out how far out that is from the actual price, 315 divided by 320 is 0.98. So in other words, it's less than 2% out from the actual price. And as a rule of thumb, if you're within 10% either way, then you're going to say it's a good model. That's the advice that we've been given. I was given as an examiner when marking some of questions of this type last year. So therefore, we're only less than 2% out, so we're going to say that it is a suitable model. Perfect. I hope you found that helpful, and I will see you in the next video.